1, 2, 3. Hello everybody. Kickstart round C starts in 20 seconds. 20 seconds. I will try to win. Also, if you're interested in 3-person group lessons, it's $60 per hour. I'm very good. I sometimes win competitions. Reach me at ericto@gmail.com if you're interested. $60 per hour. So like 90 per 1.5 hour lesson. Anyway. Count strings smaller than this one that are palindromes and use those characters. Okay, I think we will need to go from the both sides, and then what? Let's call it ACPP. It's some kind of DP. There is NK and the string. Boom, boom. Let's say it's DP of 2, 2. The first dimension says whether prefix smaller, and the second whether suffix is smaller than the corresponding suffix in S. First, like strictly smaller or what? I just care if small, if equal, that's also important. I think we need this. Equal. Well, prefix cannot be greater. So whether prefix strictly smaller or not, and here whether suffix smaller. Smaller is 2, equal is 1, and bigger is 0. First we have this is untrue, this is 1. We iterate over character to put here. That, and here we will create a new DP array like that. I will call this position. Clear this, and then for prefix smaller, and for suffix if prefix was already smaller, then it will remain smaller. If prefix is equal, then if this character is strictly smaller than this character, like there is C here, and I'm putting A or B. New prefix is this equal is 0. Then this is 1 smaller. And this is forbidden. Then this new character overrides. if this is equal, then new suffix is the same as old suffix. If now I'm using a smaller character than 2, prefix, new prefix and new suffix. Like that, and after all we copied dp to new dp. And I will need to do something special for the very last position, right? I don't think I will, but if n is free, then we do this, and then either first value must be greater, prefix must be strictly smaller, if prefix is equal and suffix is not smaller, then continue, otherwise this is allowed. Not quite there. Alright. Let's say, should I say something of like 3 maybe, and alphabet of size 3. Let's go with CBA. Is that right? A and then whatever, B then whatever. No, the answer here should be 6, so this is already wrong. Let's see. Here 1 means smaller. For every position I use 2 characters. Suffix is equal. Your suffix must be smaller. A, B. You're smaller and then you're whatever. Well, that's right. And for those 2 options, why? Oh, what happens else? I didn't specify. If it's, oh yeah, then I need to use the same value. Right? We are at 10 minutes, which I believe is a bad time for this problem. Whoa, 4 minutes. Okay, that's very slow. So we want this to happen. K plus 1 plus something plus, let's say, k plus n or so. And you can n minus 1. Should I start with k plus 1 instead? Yeah, let's start with k plus 1. This we want to be equal to g. But this on the left we have 2k plus n plus 1 divided by 2 times n is equal g. Let's transform it even more. We need to find divisors of twice g. Also, this first problem passed. Cool. We can move forward. And are they fine with squared complexity? Yes, they are fine here. So I need to iterate over divisors of this and consider n to be that divisor, or this to be that divisor, and n the other one. Well, in both cases we get n, and we have a candidate for this guy. Yeah, that's, I think, extremely easy. Boom, boom, boom. G is doubled already. Now if this is divisible, then let's say consider if this is not a perfect square, then also consider the other guy. Now what will consider do? I need to use this formula. Okay, then other minus equal n, other minus equal 1, other is smaller equal than 0, then I guess it's bad. We start with positive? Positive, yeah. Then return. Okay. What happened here? Oh, that was some old binary file. Okay, why? N can be 1, 2. Okay, we considered all the divisors of 20. Was I right here? I think so. For n equal to 1, what do we have? This is like k equal to 9, I think is what we get. Come on. So just a single one, but also we should consider k equal to 1 and n equal to 4. What happens for 4? This is 5, and this becomes 0. But that's actually fine. K can be 0 because I start from k equal to 1. Okay, cool. Now, if I get 1, that's 1, 2, 3, right, and something very big. Is it submitted? I don't know if it's submitted. I guess let's submit again. What's going on? Okay, 2 submits. I hope that doesn't hurt me. A, B done. Now on towards C. $60 rounds. There are points for winning, for draw. I think he chooses strategy based on your previous moves. I just need to come up with a good strategy, right? And maybe that differs depending on whether ties are good or not. Well, fine. Let's think about the strategy. If I play rock first, he plays random. Then he will play paper to beat my rock. I know that. So I can play scissors. Then he will play one of those ones, Sun 2. And now I need to decide. Should I do something optimal? Maybe... Yeah, well, the current state depends on how many rocks, papers and scissors I used already. And I will use +1 of something. I know what's the probability of me using everything is. And I will move to some forward state. Let's define DP as ABC as 0 if A plus B plus C is 60, because that's the end of the game, so the remaining average win is this, and I will move backwards. Again, easy DP problem. What do I read? I don't think X matters. Oh, first there is X. No, here X. many test cases? 200, that's fine. And now I need to consider 3 possible moves. I know what are the probabilities for the opponent to make all the possible decisions. Well, first the probabilities. Say by default his probabilities of moves are all 1/3. If this is not 0, now I know his probabilities of moves, and I can consider moving A. It will be something like this. dp of A, B, C is maximum of itself, and I consider moving to this state, and I have this probability of tying, and then for a tie I get this, plus let's say A beats C, A beats B, B beats C, C beats A. Then I have this probability of winning if he moves B. That's that. Done. But also I will need to know the move. Maybe 62, just to be sure that I'm not using something off bounds. Alright, dp of A, C is 0, 0, I guess, -1, -1 also will do. 0, -1. That's the score I will get on average if I make this move. And let's say 0 denotes this kind of move. While rewriting, I'm also thinking whether this is fine, but yeah, it seems fine. And now this I already rewrote once, I'm not going to do it twice. So that's it. And now starting from this state, yeah, also we can, I guess, print. No, 0. And while the round is not over, my move is this dot second. Rock beats scissors, scissors beat paper. Must be this order. This move. So I'm moving with paper. And then with scissors, rock, I don't think that's what we should do. His probabilities, yeah, he will move A a lot if I moved B a lot. I think those should be the probabilities. Now, paper. And I will use rock a few times, then he will start using paper all the time. I use scissors. Here it seems I vary a lot. Alright, is the format output good? I should maybe test it some more, but because I'm not in the top, I need to make a risk. Now to fight for top places. So I submit it. And again, there is this same issue where I don't see if I submitted. I don't. Okay, yeah, I did submit. Well, this is hard, so I will not resubmit. I mean, I will not start reading the next problem. Oh, nice. I'm winning after such a terrible start. That's great. Okay, let's go. Well, B and C were both DP problems. So I solved this optimally with DP. It's the best strategy. I don't like the fact that we deal with big numbers here, so they can give me a lot of 9s times a lot of 9s. That will be hard to do in C++. Okay, 0 times anything is 0. And that's one special rule. Other than that, I have just additions, multiplications. Every single thing inside brackets I need to treat as an expression. There can be just a number. Do I copy paste some library for big nums? I have one. And what then? If I have some expression, well, 0 times any expression is 0. Right, let's write out some rules. A plus A, I need to understand that it's the same as 2 times A. It depends which I don't know which of them is lexicographically smallest, but for the sake of detecting same equivalence classes, it's this. Oh yeah, I don't care about lexicographically small. This is the same. I can just always change like that. Then, what then? A times B times C. This is same as, just A times B times C. This doesn't matter. Generally, any kind of addition should be turned to 2 times A. What about this? 2 times A plus 3 times A. You need to understand that this is same as 5 times A. If there is, say, 2 hash 5, in 2 strings I need to understand if there exists 2 times 2 hash 5 and it's multiplied by what? Kind of what's the total multiplier, and I can use modulo values for that. I will not need to use big nums. I will just check using modulo billion 7 or something like that, I think. Right, and that's a good idea to compare values modulo big prime, so it will be basically hashing of both sides. Actually, that might be a very good idea. Let's give hash some property. Let's choose some function. Something that will be very special. And then problem is solved. What's x hash y? It cannot be swappable. Something like x at power y or something. I will create a function that will change x to a new value. And it will do this. Now what is the hash? Should I just say that it's both numbers multiplied by something? With addition? No, with addition that would be bad. No, a and b will be different values. Now does this satisfy some properties? I'm afraid so. So then I will XOR this with some kind of C. XOR this with some kind of C. D, sorry. XOR everything with some kind of Z. Then do I need hash? That doesn't hurt. A, B, C, D random. If I do this, then I can just compute the value of every expression and check if two values are the same. Then there is birthday paradox. I think I need to use values as big as 1,000,007,000. Will that be enough? Depending on how many test cases they have. Well, that many, so I can check. Yeah, that's not a problem. 1,000,007 is fine. Then also, what's hash of x? I guess. Well, then I don't need all of this, right? Do I? Should I just leave x here? It can cancel out with this guy. That's bad. I would say this. I can use more complicated functions. Alright, is this good? That's the plan. I wanted to look at the standings, but that's not a good idea. If I want to save time, I need to focus and solve a problem. I will use, let's do this. I need to choose a big prime. Different than 1,000,007 because maybe they made 1,000,007 fail. This is good. Everything will be computed modulo that. Now for every test case, we read n, and then what? We read strings. Okay. How do I go about it? There will be something like that. It's global array, and then there's recursive function. You need to repeat this obviously n times. If we have brackets, then we need to start from here. that. And then we're past closing bracket. This was inside the brackets. Let's see, if I get this, no, that's a bad example. If I get this, this is inside brackets, now I would get down to that thing. Do I want that? Maybe I want to stop here. No, I went down here. I got recursively there later. No, actually only here. Outside brackets, either this is everything, or there is now some operation. Let's call it A. This thing, and now if it's plus, return the sum. It's multiplication, return the product. It's this, return something crazy. For now it will be, let's say this. What happens here? Well, in particular, this is that, right? I will need to make this into a function. do this and L++. Finally, L is 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Maybe I need to be more careful about passing stuff. I'm passing something wrong already. From 1 to 8, that's wrong. Somewhere I need to go to R-1. Okay, this is the test. We have brackets. I should go to 1 through 7. I think it's like this. Cool. Then remove that because I don't see stuff. Oh, runtime error. Line 45. And what do you want? 0 times 2, 3. Oh, the casting to long is in proper place. Just do this. Too many zeros. That's bad. Or maybe that's good. Maybe those should be zeros. Those two values should be the same according to them. But they are not. Why? This is 0, this is 0. But why is this 0? Why is this 0? One 7 2 4 4 4. That's for sure wrong. Maybe not. Maybe not. Sorry. but why don't I have 2, 2? Oh, I have 8, so it's fine not to have 2, 2. 4, 4, that's fine. 7, 6, that's not fine. How do I get 7, 6? I guess we're trying to get this guy. This is inside brackets. Yep, that's the issue. Apparently 1, 7. So looking here, it triggers that. Okay, I see an issue. If we're starting a bracket and we finished here, then we shouldn't go to r-1. We should just go here. Does this work? Looks good to me. Great. There is some mapping. Why did I get only 2 values? I guess this is why. And finally, maybe time to improve this. What's the leaderboard situation? I can still win, so let's make a simple test then. Actually, I guess I want to improve this. This will be hash of A. This will be hash of B. A random value modulo this guy. And we will use few of those. I hope I'm not messing up probabilities with this stuff. All right. Fingers crossed. My heart is pounding. Oh. Wrong answer. If there are multiple hashes, then it becomes bad. Do I have some special property of my function? Oh, why can't I just come up with a good hashing function? I know what was wrong about the first one. I think I can think of a counter test. What about... I didn't have any interaction between A and B. 1 hash 2 plus 3 hash 4. And compare this with 1 hash 4 versus 2 hash 3, no, 3 hash 2. I believe my program will think that they are, yeah, they are the same. They are not. They are not at all. Okay, what's my first code? This guy. This was second. Was it better? No. This is better. Let's call it d2.cpp. There was no interaction between those two. Well, instead, I think I should use XOR. It's that easy. No, that's not better. How to force them to interact? Multiply them? Because with plus this happens. XOR seems better, but then I lose this info. Okay, this is better. So I was just being stupid. Now I pass this test 1, 2, 3, 4 versus 1, 4 versus 2, 3. Basically my function so far, it boiled down to hash of A plus hash of B, modulo mod. And that's not smart. Now this didn't count because for the first time I solved the first subtask. So if I pass here, I get 12 minutes of penalty. So for the next 12 minutes, if anybody solves everything, they beat me. Of course, I'm now optimistic that I understood the issue and now it will work. What did I submit? Oof, Excel. Okay. Come on. First to solve everything. Okay, cool. Now what's the time penalty? Plus 4 wrong penalty attempts. Okay, all of them are counted. Plus 16 minutes. Well, good thing is that Kevin has already 4 wrong penalties. He will not beat me. Simon, 1 wrong penalty. But this is an easy problem. Maltisen, it's 1 wrong penalty, and this is an easy problem that a lot of people solved. If only I didn't mess up so much. $15 more minutes of refreshing the leaderboard. Also, I will remind you what I announced at the beginning. I'm going to teach private classes and small groups of 3 people, 3-person groups. The price per person is $60 per hour, which likely means $90 per 1.5 hour long lesson. That will likely happen weekly, so be prepared for the monthly cost of over $300. If you cannot afford that, then of course feel free to watch my videos and streams. I still put a lot of educational content and there's so much there for free. And if you're interested, reach out to my email address. I'm so scared to refresh. I should start some kind of timer. Okay, 1:27 and it's now 1:25. 14 minutes. Half a minute more and I will start a 14-minute stopwatch. Timer, not really stopwatch. Right? Because it's now 1:15 and a little bit. Oh no, it's only 12 minutes left. People have now time 1:15 if they finish, plus 12 minutes. Yeah. So I will start a 12-minute timer. In 10 seconds I will do it. 12-minute timer. And as this happens there, I can talk about problems and a little bit more about my solutions to those set problems. I guess we want this to be much smaller. Smaller strings. I spent so much time there. Other people, I saw Tim William Lin. He solved it in like 4 minutes. No, I don't see him. I solved it in 9 minutes. It's some kind of DP where we choose characters from both ends. If you see stamp string in the input, let's say this string in the input, then if you choose to put here A, then at the end you put B, sorry, you put A at the same time. That's one possibility, and already you know that this string is smaller. Oh, I know how I should have done it easier without the DP. Yeah, I should have iterated over how long prefix will be the same, maybe Bij, and now here on this position I will put a character smaller than S. right? For example, A, B, C, I can iterate over that. So iterate first over the length of prefix to match exactly, then over the next character to use, and most likely if then this character is smaller than corresponding one, like here, let's say D is smaller than S, then sure, we put here suffix in the same way. We have some number of ways to choose the middle. It's basically what's the number of palindromes of some length. That's easy. Number of palindromes of length L is 2 to L over 2. Rounded properly, I think rounded up. So ceiling of L over 2. Not 2, that's the minor strings. Alphabet size. Alphabet size at power L over 2. That's the number of palindromes of some length. And finally, we need to handle the middle properly. I instead went with dp, and this is how I lost 5 minutes. Still first. 9 minutes 30 seconds. I really wish that now I could show you my heartbeat, because it would be interesting. Alien generator. I used a simple formula for arithmetic progression or sequence, where a plus b, a plus 1 plus a plus 2 and so on, plus a plus, say, n. The sum is first element plus the last one divided by 2, so this is the average of them, times the number of elements, in this case n plus 1. I modified this a little bit to say that, well, let's consider actually that the first number I name k plus 1, not k, and then the formula changed a little bit, but even going like this, I know that this must be equal to g, I move 2 to the other side, and I have this times n plus 1 is equal to twice g. Product of two values must be equal to this one value, so it's enough to check divisors of this one value. If this is 100, then I consider divisors to be 1, 2, 5, 10, and so on. And for each of them, that's some n and some a. If I know that, well, let's say right side is 100, then maybe here I have 5 times 20. Does this make sense? It will not, by the way. Well, then n is 19. If n plus 1 is 20, then n must be 19. And here also I can compute a. But here a will be negative, that's bad, so we don't count this thing. The complexity is the complexity of finding divisors of twice g, and that's square root of g, because it's enough to iterate up to square root of a number to find all the divisors. Basic factorization. Still winning. Okay, somebody got the full score as well, but with worse total penalty, 3 wrong submissions. 1 fewer and I would lose. And now this 7 minutes means that some people already cannot beat me. Kevin cannot. Everybody with 2 or more wrong submissions. Zeng cannot beat me. Maltisen can still do that. It will be very nice to see this past 4 minutes. If that's below 4 minutes, plus maybe 1 minute for judging. The leaderboard refreshes once a minute and you don't get the verdict for your submission immediately. So if I see here 3 minutes on the right and I'm still winning, then only somebody who doesn't have any wrong submissions can beat me. Also Maxim now cannot do it. And I would say people with time bigger than 1 hour in ABC, they are not likely to solve the last problem very fast. Still first place. Rock, paper, scissors. I recall a similar problem recently from CodeGem or something. I think, yeah, from CodeGem. It was maybe interactive with heights of towers. So it was Google CodeGem, maybe around 1 or so, where there were towers of length up to 15. Anyway, what I did here is the statement says what's the probability for every situation, like every state. Let's say that I used 10 times rock, 15 times I used paper, and only twice I used scissors. With this, we can compute probability of how my opponent will move. And I think because I used paper so many times, 15 times. 15 divided by all my moves, 27. That's probability that my opponent will try to beat paper, so he will use scissors for my opponent. And so on, I can choose the 3 probabilities. And then, depending on my move, if I know those 3 probabilities, let's finish this. There is 10 over 27, this is probability that my opponent will move in such a way to beat rock, that's paper. 27, probability for what's left, rock. And now, being in this state, I can consider moving with, let's say, rook, with scissors and paper. Maybe it's not obvious what I should do, because I shouldn't just care about the improvement right now of the score, but also the future ones. You might say that greedily, because he will most likely use this, maybe I should beat scissors and I should use rock. Or maybe we should just consider each of 3 possibilities, compute the expected value of how much I gain right now, but maybe then I will be in a worse situation. And I think that would happen. Because it's actually very nice that we're in this state where probabilities for my opponent to move in every way is so special. Like that, right? I know he will not use rock, so I'm quite safe to use scissors. That's something, that means a lot. And with scissors I will draw or I will win if he uses paper. So this state is better than evenly, like every type I already bet 9 times, let's say. In total that's 27. So when I consider moving rock, let's say I consider moving rock, then I have some probability that he moves scissor. So this is expected win for me. With this probability I win this much. Also with this probability I tie. And then I move to state described by values 11, 15, 2. If I know already how much on average I will gain until the end from this state, then the more the better, of course. So in total, this is how much on average I will gain in this move plus all the future moves. So if I move rock, I have this, assuming that I already know how much I gain on average from this state until the end of the game. If I move paper, I also have some value. If I move scissors, I also have some value. And I need to choose the maximum out of those 3. And I remember what move I make. And then I know what's the average value I gain from state 10, 15, 2. This was 3-dimensional DP in complexity 60 squared, not squared, cubic per test. And 60 cubic is not a lot. Okay. Please. Yes. Nice. 2 minutes left. And then nobody else can beat me. And already Maxim cannot do it. Marshmallow can, if he solves the last problem immediately, like in the next 2 minutes and without wrong penalties. Same with Weasel, same with, for example, Mahan Rag Cook and few other people. But already, for example, this person is out because of wrong submission. That's plus 4 minutes. Let me increase the camera size for you to see my emotions better. Yes, so rock, paper, scissors, and we have one more problem, binary operator. In this problem, I chose some function for the hash operator and then computed the value of every expression. The important thing for this function, for hash, was not to have any properties. For example, A hash B shouldn't be equal to B hash A, because there is a name for this. Like operations in general in math, they can be transitive and so on. I don't know the names. If I choose good enough hashing function, let's say, And for example, I didn't want to rely on the fact that if one of those values is 0, then 0 hash something is 0. That would be bad as well. And with my plus here, the issue was that those two numbers AB, they don't interact. And then if I have A hash B, and then plus, somebody tells me plus, C hash D, if I swap B and D here, that doesn't change the value of the whole expression. Hold. A bit like in poker when, you wait to see that next card. Now, let's say 30 seconds more for the judging to be done, in case somebody submitted. If somebody submits right now, they have time of 1, 27, and 45 seconds. That's more than I have. So now we are only waiting for existing submissions. Yeah. I will wait 20 more seconds and then I'm declaring my win. Ten more seconds. And that's it. That's the win. Nice. It's not that, it's a huge achievement, because a lot of strong people, they just don't participate in Kickstart rounds. So I'm not here the best in the world. There were a few very strong people here, and that's it. Like, for example, William, Simon I know from a few contests. Maxim, I think, is also very high in code forces. But most people, they just skip it, especially because today there is Open Cup 5-hour contest for teams, and that's much higher levels. This is kind of like Division 2, open for everybody. Not everybody bothers participating. And my feelings on this round are the following. Smaller strings, I messed up. I chose a bad strategy. And then B is very easy. I would swap those two problems, smaller strings and alien generator. This one is easier, it's just simple math and finding divisors. Rock, paper, scissors, for me it was very standard, but I'm happy to see such problems because I can do them very fast. I did it in 11 minutes. If I look at times of people in the top, I think other people will have strictly more than 10 minutes. Notice how after solving C, after solving ABC, I was the first. I was the first to solve ABC, even though I had bad time here. And binary operator, I saw that technique somewhere. I first thought about making lexicographically smallest possible expression equivalent to something, and maybe that's possible, but I'm very happy I finally got the idea. I'm unhappy about my wrong atoms. Rock, paper, scissors was fine. This one too easy. Smaller strings, I know I messed up. Binary operator, cool, but would be for sure too standard for a big contest like Google Coach. But a fine problem for Kickstart, which is just easier version of coaching. One last refresh. Now, if somebody submits now, it's time of 1:30. So I'm happy. This is my, I think, first Kickstart in this year and the first win. The previous two Kickstarts, they were in the middle of the night, like 3 a.m., 1 a.m., and I prefer to sleep then. Competitions on air, what is that? Oh, it's just some videos. Don't treat those as something very useful. If you want to become very strong, I have a... Why is this? No, I'm not logged in, and this is not dark mode. Anyway, in the description of this YouTube video, you will see how to practice page, where I explained how I think you should practice. Basically, solve problems, and read editorials. Even here, if you didn't solve a problem, afterwards, after the contest, somewhere here, you will see a button analysis. Read it, and absolve the problem, which means implement a solution after understanding it from the editorial. This, repeated like 1,000 times, is enough to become good. Repeated 10,000 times, it's enough to be one of the best in the world, if you have strong math background, I guess. Alright, this is it. Thank you everybody for watching. Also, in case you want to see something here, I guess I covered some parts. In particular, I covered the remaining time. So thank you all for watching. I'm happy about my performance, and actually I will see you in a few hours, because it's Sunday evening right now. I have a stream. By the way, go follow twitch.tv/ericto. I stream 3 times a week in Europe evenings. Alright, see ya, bye.